Mr. Abbott again. Another perspective here on the Earth's tilt and the seasons. All right, you should know that no matter what day of the year it is, the Earth is always tilted or inclined by 23.5 degrees, but on each seasonal date, the tilt is either more or less towards the sun's rays. So we've got 4 diagrams here. Right, on each one of the diagrams, the arrows that you see representing on the right are supposed to be the sun's rays. Now, on each one of these, there's a darker, bolder ray. That darker, bolder ray is supposed to represent the vertical ray. The vertical ray is the point where the sun's rays are shining directly. So, if you looked at it, if you were standing at the location of the vertical ray, the sun would be hitting at exactly a 90-degree angle. One of the skills you have to be able to visualize is the sun is coming from the right in these diagrams, which means in every single one of these pictures, the left side of the Earth is going to be in darkness or unilluminated. So I'm going to very carefully draw a line straight up. It goes right through this point, straight up through, and I'm going to shade that this half of the Earth would be in darkness. All right, now that line that separates light from dark is called the Terminator. When I'm looking at this diagram, okay, I'm looking that the vertical ray is hitting this line, which is 23.5 degrees above the equator. So that line is 23.5 degrees north. So the season when the vertical ray hits that line is definitely going to be the summer solstice. So this one is going to represent 6/21. It's our summer solstice, and the sun is shining directly at 23.5 degrees north, which is the Tropic of Cancer. If you don't remember where Cancer and Capricorn are, you can definitely look at the Earth Science reference tables. On page 4, they label all the lines that we need to know for the seasons. Now, the relative length of daylight in New York, the summer solstice is the longest period of daylight hours for us. We get about 15 hours of daylight on the summer solstice. Now, the second diagram, I'm going to label that the vertical ray. I will shade in, once again, that half of the planet that is in darkness. Okay, no matter where the Earth is, 50% of the planet is getting daylight, and 50% of the planet is getting darkness. Over an entire year, every location is going to receive 6 months of daylight and 6 months of darkness. Now, for this diagram, you see the vertical ray hitting the equator. So, the vertical ray is hitting the equator, which is at 0 degrees. We know that this is definitely going to be an equinox. So this is either spring or fall. Now, to tell whether it's spring or fall, you have to know whether the vertical ray is moving north or south. All right. One thing that you'll notice on this one, okay, if I look at the North Pole, when the North Pole is on the Terminator, that means it's got to be an equinox. So this is going to be 9/23 or 3/21. You know it's an equinox when the poles are on the Terminator or the vertical ray of the sun hits the equator. Now, for every single line of latitude, even if I drew a new one in here, half of it is in light and half of it is in darkness. So for every point on the planet, what's going to happen is you get 12 hours of daylight and 12 hours of night. All right, third diagram. We're only going to do one equinox diagram because they would look the same. The sun's rays are coming from the right, so the Terminator is going to be straight up and down. 50% of the Earth is in light, and 50% of the Earth is in darkness. All right, that's what you would see from space. All right. Now, when I'm looking at this date, I notice that the vertical ray, the 90-degree angle, has shifted into the southern hemisphere. So the sun's vertical ray is hitting at 23.5 degrees south. So the vertical ray is on the Tropic of Cancer. So this is going to be 23.5 degrees south, or the Tropic of, I misspoke, Capricorn, sorry. Now, the season in New York, this would be our winter solstice. The date is definitely going to be 12/21. Now, I'm looking at the equator. The equator is always half light, half dark. So no matter what day of the year it is, if they were to ask you about the equator, you get 12 hours of daylight and 12 hours of darkness every single day at the equator. Now, on the bottom, you'll see that the entire Antarctic Circle is in light. So this would be 66.5 degrees south, and you'd be experiencing 24 hours of daylight for any location south of the Antarctic Circle. Since the bottom 23.5 degrees is in light, if you were to observe this, you'd see the top 23.5 degrees, or everything from 66.5 degrees north, is going to be in complete darkness. So you'd be going from 24 hours for the Antarctic Circle to 12 hours at the equator, all the way up to 0 hours for the length of daylight for an observer north of the Arctic Circle. Now, New York is somewhere around 41, 42 degrees, and I didn't draw that line very well. But you would at least get the idea that for any location north of the equator on this date, you're getting less light and more darkness. For us, the winter solstice represents the shortest period of daylight hours, and we get about 9 hours on the winter solstice. So we gain 3 and we lose 3. When you add the values for summer and winter, it's always going to add up to 24, because however many hours you gain in the summer, you lose in the winter. Now, the one thing I'd like you to add, okay, in the spring, you would know it's the spring equinox because the vertical ray is moving north, and sunrise is also moving north each day. If it's the fall equinox, the next day you'd get fewer daylight hours, and for the fall equinox, the vertical ray is going to be moving south, and sunset, your sunset position is going to move south as well. I hope going through these diagrams has helped you and your understanding of the seasons. Take care.